Oh, welcome from my side as well. That was quite an introduction. So again, hope you're enjoying your Hashi Talks 2024. It's good to be back. And today I would like to talk a little bit more about the new testing framework and how we can kind of use that for testing our Terraform module specifically. So we're going to be kind of focusing on that, kind of see what kind of options we have and how to address that. So before we kind of dive into nitty-gritty details, I would like to start with a short story. So there is a really famous bridge and just kind of south of Scottish Highlands. It's called the Tay Bridge, which was actually built at the end of the 19th century. So it was actually opened in 1878, and once they finished the bridge, they actually did the initial testing in like really sunny, good weather, and the train went through, and the inspectors actually kind of checked it out. So like, oh, the bridge is working fine, everything is okay. It was one of the biggest kind of engineering achievements back in the day. But they have left a note there at the initial testing saying that we would definitely like to see that bridge in high winds, but obviously because there were high pressures from the building company and the government to open the bridge as soon as possible to enable the economy kind of growing, they were kind of pressured to open it soon. And shortly after its opening, so after it was opened in 1878, just a year after 1878, there was a horrible disaster where in December there was a big storm and actually the bridge collapsed during the high winds. So, it's hard to say if this could be prevented, but with some additional testing, definitely feels like, huge disasters can be avoided, or at least the risk could be minimalized. But something else to keep in mind, since we're talking about like testing and making sure that things work, is also keeping in mind that the testing only shows the presence, but not the absence of bugs. So this is kind of a famous quote from E. Dijkstra for specifically for the software testing. Right. Quickly about me. Who am I? Why am I here talking to you about that? So I'm the head of consultancy at the Scale Factory. We are UK-based AWS consultancy specializing in SaaS B2B businesses. I come from an ops background, so I wore different hats through my career. So I was doing everything from sysadmin things all the way to like architecting and designing like really complex systems. And currently, like I mentioned, I work as a principal consultant and head of consultancy at the Scale Factory, where I think I had a good opportunity to kind of see different kind of customers, how they operate, and kind of see different patterns emerge and kind of get a good sense of what kind of works, what doesn't work, what are the usual kind of shortcuts that people take. I'm also a HashiCorp ambassador as well, as well as the OpenUK ambassador. I'm also an open source contributor, maintainer, and supporter. You can find me in community. I'm actually one of the maintainers for the RVCD Helm charts. And when I'm not spending my time behind screen, I'm a big fan of hiking, traveling, and exploring new places. So really looking forward to new Hashi days that have just been announced as well. I'm also on all different social media, so feel free to reach out. I'll be hanging around in the YouTube channel afterwards if you have any questions, but feel free to reach out or connect. I'm happy to kind of have those discussions offline as well. Right, so let's get this started. So firstly, if you look at the software testing in general, you're probably aware of the Agile Software Development Manifesto kind of testing pyramid. It's kind of a very famous thing that people usually look at as soon as they start thinking about testing, right? And broadly speaking, you can say, testing pyramid represents different complexity and different kind of cost related to specific testing and kind of speed of testing as well. So if you start at the bottom, you usually have like unit testing, which is a kind of a scope testing for specific units. It can test a specific functionality for a limited scope, and it's a quite quick way of discovering and quick way of testing things, and it's fairly cheap. And as you move towards the up of the pyramid, then you end up with the component testing or contract testing, which it can sometimes be called, where you will test different kind of relationship between different components. And as you move up, the next stage is usually the integration testing, where you actually test your system, how it actually works when it's all kind of built together. So for example, if you deploy a software, you want to test it with all different components and all different external systems, how that interacts. And the last stage would then be complete end-to-end testing, where you actually test all the services involved and all the either internal, external systems. And usually at that stage, people would kind of check the OU as well and those kind of bugs. And at the top of the pyramid, it's not marked as part of the pyramid in my kind of diagram here, but there is a manual testing as well that you can actually do for specific use cases or edge cases that might not be captured by automatic testing. And like I said, in the pyramid, there is an interesting kind of a relationship where, the higher you go up the pyramid, the tests become slower, more complex, and more expensive, as well as kind of finding bugs later on in the testing can be more expensive as well. If you kind of take a step back and kind of look from a really high perspective, you could say the lower part of the pyramid is kind of technology facing tests. So are we building the system right? And the higher part of the pyramid is kind of more business facing testing. And the question that we're trying to answer is, are we building the right system? So is the system doing the things that it should be doing from the business perspective? So, this is how, the software is usually tested. But then, the question remains, how about our infrastructure as code, something like Terraform, right? Like, can we use the similar approach or similar techniques, for our infrastructure as a code? And, up to the recent 1.6 release, there wasn't actually a lot of options for that. And we will kind of dive into that just a bit. But if we look how the kind of testing landscape looked like up to this point, obviously there are different testing strategies you can use. So you can start with linting, syntax checking. So in Terraform, that would translate into Terraform formatting or Terraform validation that you can kind of run on your Terraform configuration. Then, as I mentioned, you can do unit testing, integration testing, complete end-to-end, or drift detection even. And there is a variety of external tooling that you can use for that. So, as I mentioned before, you can use something like tflint for linting. You could use something like terratest from Gruntworks that would kind of do like complete unit testing or, contract testing for you. But maybe one of the downsides of that is you probably need to learn Go, which most of the people in the industry kind of responsible or owning the Terraform configuration are probably not very fluent with, or maybe not something they want to pick up. You can actually use something like Kitchen Terraform, Test Harness to kind of execute and test the integration testing bits and the later bits. With the release 1.6. Kitchen Terraform was actually obsoleted or deprecated in favor of features that are actually part of Terraform now, which we will talk just in a bit. And, in terms of other tooling, there was also Checo, TFSec, Terrascan, or Terraform compliance tools that were mostly just static analysis tools to check for, either compliance or any other kind of, static analysis that you can do in your configuration. And as I mentioned earlier, you could do drift detection, which there is a tool called driftctl, which was actually kind of acquired, kind of bought under the Snyk umbrella a couple of years back. And if you're using something like CDK TF, obviously, it gives you the full-blown, programmatic language kind of functionality. So you could do all the spectrum of testing from unit test to jest. And depending on which kind of programming language you're using, you can use different tooling to kind of do the full-blown testing there. And obviously, there are also policies that you can use, such as Sentinel, OPA, or ConfDesk, where you can actually use Rego or similar kind of policy language to kind of test for validity of the configuration best based on the guardrails or organizational requirements that you might have. So, if we look at the whole kind of the, landscape of tooling, it might actually look something like that. So, there are a lot of different tools available, each of them kind of trying to solve a different problem. And, looking at this kind of, slide kind of always reminds me for some reason of CNCF landscape, where, there is a plethora of tooling, but, coming into the space or trying to pick the right one is probably can be quite challenging, right? And can introduce a lot of complexity, in the way how you manage your infrastructure as code. So, following the, kind of the approach of trying to keep it simple, what the idea here is, you're always trying to obviously run your workloads with the least effort, but still kind of not sacrificing the good industry practices that we acquired. So obviously it needs to be simple, but at the same time, you still want to kind of check all the boxes in terms of like, is my code properly formatted? Is my code, tested, adhering to specific policies and things like that? And, even though lately the name of the game is usually complexity, the usual aim, what we've seen working with our customers, is usually everybody's trying to kind of abstract the complexity or remove the complexity away, and trying to lower the cognitive overload that engineers and developers need to kind of have in order to kind of operate within the system, right? And even though you can usually you cannot really remove the complexity completely, but you can move it in a place where you feel comfortable kind of or have it managed in a way that you can kind of work with it. Also, what we're usually looking for is quick feedback loops with having something like local execution. So ideally you want to have tests executed in a similar way locally as well as remotely. Or if you're using, a SaaS system such as Terraform Cloud, you would expect the experience should be quite similar, if not the same. And obviously, you want to detect issues quite early on, as I mentioned earlier with the testing pyramid. The longer it takes, the more expensive it usually is to kind of fix the bugs, right? So there is the whole kind of a industry shift left in terms of like pushing everything left and detecting everything as early as possible. So if we look back with 015, and that I mean Terraform, there was actually an experimental provider which kind of opened up a possibility of thinking of how could we actually test things directly from Terraform using HCL. And that was actually a really good start, to be fair. But it came with some really strict limitations in terms of what you could do and what you cannot do, just because the way how providers have visibility over specific resources or not. With the release of 1.6, that actually brought a new testing framework in Terraform, and it's part of the language now. What it enables you to do is actually consistently validate the functionality of configuration, and at the same time ensuring that you can do it safely without kind of breaking or influencing anything else. Like I mentioned, it's using HashiCorp configuration language syntax, which people are already kind of familiar with, because if they're using Terraform, this is kind of the native way how to configure infrastructure. And for more comprehensive testing, you can actually use things like help modules, which can be invoked directly from testing files directly. So the main features I think it's worth kind of stressing out here or pointing out are definitely the configuration is using the same HCL syntax. So the new suffix was introduced .tftest.hcs files, where you can define your tests. Usually you can put all of those tests in the tests subfolder within your module. So either you have it in the root of the module or in the test subfolder. The Terraform would automatically pick that up if you execute Terraform test. The tests are defined by so-called run blocks, and within the run block, you can actually define either your testing functionality at the plan stage or at the apply stage. And then you can specify, a custom set of assertions and checks which you want to execute on that stage. And something to be aware of as well, when you're executing a test, it's actually provisioning real infrastructure, which can infer real costs. But it has the automation built in where after a successful test, it will go and destroy the infrastructure that it has provisioned for testing. So it kind of automates the whole life cycle quite nicely. And, previously you would have to kind of manage that separately, kind of run your own scripts or, run helper modules to kind of speed up infrastructure and make sure that you're kind of tearing that at the end of it. I'm going to briefly touch what kind of came with release 1.7, which is the latest stable release. That actually introduced a lot of really cool features around mocking, which I think are quite useful things to have. So, for example, what you can actually mock now is the whole provider. So the tests that execute in the apply mode, they can actually interact with completely mocked providers. You can define, arbitrary resources, and no infrastructure actually needs to be provisioned. I'm going to talk about specific use cases while we jump into the demo. You can mock modules as well. So instead of testing the whole module functionality, you can actually mock values for specific bits, such as resources, data resources, or the whole modules as such. So you don't need to rely on spinning those resources in the backend somewhere, specifically if those take really long time to kind of spin up. Obviously introduce some fixes and general stability improvements and other things such as import-driven, config-driven imports and remove blocks, which kind of brings us with the parity with CLI parity actually. So what we've been used to using from the CLI previously, now it can actually be driven by the config itself. Cool. Just before we kind of jump into the demo, really quickly, as I mentioned, one of the kind of goals here is also having quick feedback loops. So the testing, you want to have tests part of your usual workflow. So either that would be development, where you're testing your Terraform configuration. So the tests are part of your pipeline where you plan, do some unit testing, apply integration testing end to end, and actually deploy your infrastructure at the end, and then you kind of provision it or promote it to production if that succeeds. And at this, on the opposite side of the spectrum, you probably want to test your Terraform modules as well, which I'm going to be specifically focusing my demo is, during, developing new modules, you want to have quick feedback loop and detect issues quite early. So when you commit code in, you definitely want to have plan and apply tests executed immediately and infrastructure automatically destroyed at the end. Right, real quickly, how the structure kind of looks like for a typical project. So, everything stays the same. Like I mentioned, the new thing is the test subfolder, or if you're dropping that directly in the root folder, that works as well. I kind of prefer the test subfolder. I think it kind of nicely separates the tests from the main configuration. And then usually you can actually have, the recommendation is to use something like testing subfolder, where you actually define the this kind of supportive modules that you need to spin up or query for specific parts of an infrastructure as part of the test. It's if we look from the functionality perspective, how that looks like, it's fairly straightforward. So first, you obviously need to do Terraform init, which kind of initialize all the modules and providers, and then you just execute Terraform test. You can provide different filters as well. So, for example, you can target specific tests instead of the whole test suite that automatically gets ingested. And you can see the output in lower right example here, where when you execute it, kind of spins up infrastructure, run the tests, check everything is fine, and tears out infrastructure at the end, and kind of shows that the quick summary of that as well. Right, so without the further ado, let's jump into the terminal. I'm just gonna quickly jump here. What I'm gonna do first is I'm just gonna quickly open my AWS console just to just to kind of demonstrate something as we go along. So I'm just gonna quickly open it up. Please bear with me for a bit. I should have prepared it earlier, but the problem with this is the credentials can expire, which is a little bit annoying. It's gonna make that slightly bigger so you can read it. So what I'm showing you here is S3 buckets. So obviously you can see I only have 2 S3 buckets, something coming from my infrastructure, and there is just an example of StateTF stuff, which is quite irrelevant for the demo. But what I want to show you is, if I move quickly back to my console, what I have here, it's a really kind of simplified module to deploy an S3 hosted website. If you look at the code real quickly, you're going to see there is nothing really kind of complex in there. We're just creating an S3 bucket. We are setting bucket configurations, so it's hosting our website. We're defining index, error, HTMLs. We're defining policies and making it publicly available. And at the end of it, we are obviously uploading the S3 objects that we have in our module as well. So it's a very simplified version of it. And as a second thing, we are defining a backend as well. So for the backend, we're going to use AWS EC2 and the RDS instance. So we're just kind of spinning that up as an example of a backend. So that's not going to be completely kind of fully functional demo, but just to kind of give you a sense how that might look like in the real world scenario. And the interesting bit here is, if we look at the tests, right? I'm going to quickly show you the first one that I've defined, which is actually a testing suite to test our website. So what are we doing in the first stage? First, we're obviously defining providers. We can define one or multiple providers. We can define global variables, which can be overridden in a specific test as well. And then what we're doing first is, the first step is actually, we are calling an external module, which is just a module to kind of set up a random bucket prefix. I'm going to show you just in a bit. What I'm doing is just kind of creating a prefix from a bucket. And the second test is actually the test that's actually going to execute things. So what we're doing is, we want to check the apply stage. We're kind of setting the variables, the bucket name, which is using actually an output from our previous run, which is setup tests. And we're kind of getting the output from there, which is kind of setting the bucket prefix, making it unique, and we're just attaching something at the end. And then what we're doing next is, we are creating an assertion, and the condition is the bucket name needs to match what we actually generated. So when the bucket is created, we want to expect that to match. And we're also checking the e tags with the objects that we're putting in. And the last bit, what we're doing here is, we also want to check that the website is running and it's returning a specific status code. So in this point, we are getting the website endpoint, which is an S3 endpoint, and just checking that the endpoint is returning a specific HTTP status code. In this case, it's 200. And at this point, we're just overriding some resources. What I mentioned before, we're gonna be overriding the resource for EC2 instance and DB instance, just because that would take really long to take. So it's just gonna be mocked instances. So Terraform is just gonna provide mock values for us. It's just the default values from the resource. So if we quickly execute the test, I'm just gonna execute the test here, which is gonna be literally Terraform test. So as soon as I execute that, I'm just gonna quickly go here and just show you that it's actually creating infrastructure. So if you refresh that for a bit, you're going to see it actually created an S3 bucket in my Ireland region. It's just testing it now, and it's already deleted because it has finished. So if I move back here, you're going to see I actually spun up it has spun up an S3 bucket. It ran the tests, and it kind of destroyed the infrastructure, and everything passed. So just to show you that we can actually make this fail, I'm just going to quickly change this to 201, for example. I'm just going to run it here, but this time I'm actually going to run it. I'm going to run it in my cloud environment. So I actually have this module published in my in my Terraform cloud. So you're going to see that I'm actually submitting tests to be ran in my Terraform cloud instead of locally. The output will be exactly the same, but as you're going to see, it's actually going to do the same thing. So if you look at this here, you can see I have this module in my local registry. And really looking here, you're going to see the test actually has started. I initiated that manually. It will be initiated automatically if I push something to or open a PR in my main branch. It would run that as well. And you're going to recognize the output is very similar to what you've been used to of running applies and plans for your Terraform configuration. So if we move back to here, you're going to see it's failing now because, as I said, the website is responding with 200. We're actually expecting 201, and that's why it's failing. And as you can see, you can do all kind of different things here as well. I'm just going to quickly show you how that might look like for mocking. So obviously, like I mentioned, I'm mocking the resources for EC2 instances and DB instances. And I actually have a test here to check the backend as well. And it's literally checking the tag set on the backend and the username for the instance. But because those are mocked, those are actually not being spun up. And it's just kind of testing things without using the real infrastructure for it. And you can actually overwrite everything there. Right, let's move back in here. Right here. So just to quickly wrap up, I know we're kind of running up to time already. So by using the built-in testing framework, I definitely believe it removes the complexity and kind of consolidates all the previous kind of tool chain that we've seen and kind of consolidates everything to be run within the Terraform now. I think it's a low entry bar as well. So we're using the same language, HCL version 2, that we've been using for the rest of the configuration. My kind of general observation is by using that for a bit now, docs and its ergonomics are still improving. So please do expect it's going to improve over time. It can be slightly rough around the edges. So for example, when you're submitting a job to run in Terraform Cloud, if you're not in the module folder, it would submit it from the folder where you're currently at. So I think that's kind of making it slightly less obvious what it's doing. But if you're just using the pipelines, it will do what it needs to do. So that's still fine. By using the testing, obviously, you get the benefits of consistencies across different teams where quality is ensured and empowers the collaboration. So, you can integrate that within your internal developer platform where test is part of your pipeline. And if the test doesn't pass, the thing is not being pushed anywhere deployed. As you've seen in the demo, it offers really quick feedback loops where you can actually, execute that either locally or as part of the pipeline. And, it has obviously the Terraform Cloud integration, which makes it quite streamlined in terms of, you can have this as an extra check if you're already using Terraform for publishing your modules or Terraform generation. I haven't really showed you, but there is a kind of a beta functionality in Terraform Cloud where you can actually use generative AI to automatically generate your tests on modules. It's, like I mentioned, it's still beta. It does provide an interesting approach how to generate that instead of writing it on your own. But what I've seen so far, it's probably quite limited in terms of it generates basic testing. But for anything more complex, you would still probably need to go and do that manually. And just to conclude, like I mentioned earlier, you cannot really destroy complexity, only move it to a place where it's more manageable. And I think by using, Terraform testing framework, that definitely makes it so. And coming back to the original story, if you do your testing early, these disasters can be avoided or the risk can be minimized. So thank you for your attention. Thank you for your time. I'll be hanging around in the chat for Q&A. And again, feel free to reach out or contact me via any social media or anything else. Thank you.